A dice is thrown once. Find the probability of getting a prime number, a number lying between 2 and 6, and an odd number. Now, when we have a dice, the number of possible outcomes will be 1, 2, 3, 4, 5, 6. These are the total outcomes which are equal to 6. In the first case, we have a prime number. So, for favorable outcomes, that is of a prime number, prime number is a number that has got just 2 factors. Now, 1, remember, is not a prime number. So, the prime numbers are 2, 3 and 5. So, total we have 3 prime numbers. So, the probability of getting a prime number equal to 3 favorable outcomes, 6 is total outcomes. So, that would be 1 out of 2. Next is a number lying between 2 and 6. So, the favorable outcomes is a number between 2 and 6. The numbers between 2 and 6 would be 3, 4, 5. So, we have 3 numbers lying between 2 and 6. So, the probability of number lying between 2 and 6 equal to favorable outcomes over total outcomes, that is 1 by 2. And for the third one, an odd number, third. So, favorable outcome, now the odd numbers are like 1, 3, 5, we have 3 odd numbers, so 3 odd numbers. So, the probability of getting odd number is 3, favorable outcome, total outcome 6, that is 1 by 2. This is a card on, this is a sum on cards, so we just go through the cards and see. So, we have the black cards, and the black cards are, we have the spades, and we have the clubs, which are black. The clubs look something like this, and the spades are this. They look something like this. So we have the spades and the clubs, which are the black cards. They start from 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we have a jack, we have the queen, we have the king, and we have the ace. The same thing for clubs. We have 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, and the ace. So, these are the black cards. Then we have the red cards. The red cards are that of the heart and the diamonds. So, the hearts, you have the hearts here, which are again starting with 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, ace. And when it comes to the diamonds, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, and ace. So in total we have 52 cards. There are 13 spades, 13 clubs, 13 hearts, and 13 diamonds. The first sum is find the probability a king of a red color. So how many red kings do we have? If you look up here, we have 2 red kings. So favorable outcome, here first one, the probability of a red king is 2 out of 52 cards. The next question, they say a face card. Now what is a face card? All this, the Jack, Queen, King, these are all face cards. And if you see, we have 3 plus 3 plus 3 plus 3. We have 12 face. Here we see that we have 12 face cards. For the second, so the probability of a face card is 12 out of 52. Next is a red face card. Now for a red face card, these are the red face cards here. This is a red face card. So red face card, we see we have 6 of them. So the probability of a red face card will be 6 out of 52. Then next we have the Jack of Hearts. Now when you go to Jack of Hearts, we just have 1 Jack of Hearts. Here, this is the Jack of Hearts, just 1. So here probability of Jack of Hearts is 1 out of 52. The next is the probability of a spade. Now how many spades do we have? Here are the spades. These are the spades. We have 13 spades. So the probability of getting a spade is 13 out of 52. And the last one is the probability of getting a queen of diamonds. Now where is queen of diamonds? Here is only 1 queen of diamonds. So the probability of getting a queen of diamond is just 1 out of 52. The 5 cards, a 10, Jack, Queen, King, Ace of diamonds are well shuffled with the face downwards. 1 card is picked up. Now here we just have 5 cards. So let's write down which are the 5 cards that we have. We have a 10, we have a Jack, we have a Queen, King and Ace. I should put it in red because these are all of diamonds. 10 of diamonds, a Jack of diamonds, we have a Queen of diamonds, a King of diamonds and a Ace of diamonds. The first question is, what is the probability that the card is a queen? Now we just have 1 queen, right? So the probability that it is a queen will be 1 favorable outcome. Total outcomes, we have 5 cards. So 1 out of 5. The next question, what is the probability if the queen is drawn and put aside? What is the probability that the second card picked is an ace or a queen? Now the queen is put aside, so we take away the queen. Now let's see what is the probability. It is an ace. So for the second probability, it is an ace. Now remember, the total cards now are just, we have just 1, 2, 3, 4 cards, no longer 5. So we have 4 cards, and out of the ace there's only 1 which is an ace, so 1 out of 4. And next is, what is the probability is a queen? There are no queens anymore. Probability it is a queen. There are no queens. 0 out of 4, which is 0. 12 defective pens are accidentally mixed with 132 good pens. So we have 2 kinds of pens. We have the good pens which are 132, and then we have a defective pens. There are 12 of them. So when you mix both of these, the total pens now you add them up will be 144. So this is total outcome. Total outcome equal to 144. The question is, what is the probability that the pen out of it is a good one? So the probability of getting a good pen is, how many good do we have? 132. So 132 over 144 is favorable outcome, and in this case favorable outcome is a good pen over total outcome. That's 132 out of 144. You reduce it and the answer comes 11 over 12. A lot of 20 bulbs contain 4 defective bulbs. One bulb is drawn at random from the lot. What is the probability that this bulb is defective? So for the first sum, total bulbs equal to 20. So total outcomes will be 20. The defective bulbs are 4. So we have to here find the probability that the bulb is defective. So to find this probability that bulb is defective, it will be favorable outcome over total outcome. Now here the favorable outcome is that of a defective bulb. So 4, total outcome 20. So it will be 1 out of 5, which is the probability of a defective bulb. Now in the second part, suppose the bulb drawn is not defective and is not replaced. So one bulb, a good bulb, has been removed. So the total bulbs now is 20 minus 1, and that is 19. We need to find the probability that the bulb is not defective. So non-defective bulbs. Now for the non-defective bulbs will be, now we just have 19 bulbs because one has been removed and not replaced. Minus 4. 4 bulbs are defective. We saw the 4 bulbs are defective. So the non-defective bulbs are now 19 minus 4, and which is 15. So the probability of now getting a non-defective bulb is 15. Favorable outcomes over total outcomes is 19. Just to go over this again, now in this sum, first there were 20 bulbs, and out of the 20 bulbs 4 were defective. Then one bulb was removed, one good bulb was removed, which means now the bulbs were 19. But the number of defective bulbs remained the same. There were 4 only, because the bulb that was removed was a good bulb. So now there were 4 defective bulbs and 15 good bulbs. A box contains 90 discs, which has numbers 1 to 90. If one disc is drawn at random from the box, find the probability that it bears a 2-digit number. So first we will see total outcomes as always. Total outcomes. There are numbers 1 to 90. So the total outcomes will be 90. There are 90 discs. In the first case, we have to find a 2-digit number. So favorable outcomes is a 2-digit number. 2-digit number. Now what are 2-digit numbers? Are numbers that have 2 digits. The first 2-digit number is 90, and in this case our numbers are is 10. The first 2-digit number is 10, and then we have till 90. So the number, how many numbers do we have? Then how many 2-digit numbers do we have? 90 minus 10 plus 1, and that would be 80 plus 1. 81 2-digit numbers. So the number of 2 digits in this are 81. So the probability of getting 2-digit numbers equal to 81 over total we know is 90. So 81 over 90, and if you reduce this you get 9 out of 10. In the second case we have to find a perfect square. So we have to see how many perfect squares are there between 10, 1 and 90. So here favorable outcome. And remember, for what is favorable outcome in this case? A perfect square. Now who are perfect squares? Which are perfect squares? 1 is a perfect square. 2, no. Then we have 2 square, that is 4. Then we have 3 square, and that is 9. Then we have 4 square, that is 16. Then we have 5 square, that is 25. 6 square, that is 36. Then we have 7 square, and that is 49. Then we have, that's 49. We have 8 square, and that is 64. And then we have 9 square, that is 81. Now 10 square is 100, so that cannot be included. So how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 perfect squares. So the number of favorable outcomes in this case is equal to 9. So probability of a perfect square equal to favorable outcomes, that is 9, over total outcomes is 90. So 1 out of 10 is the probability of getting a perfect square. Next, a number divisible by 5. So for the third, number divisible by 5, and that should lie between 1 and 90. Right, so numbers divisible by 5 between 1 and 90 will be 5, 10, 15, 20, and you'll go on here till 90. And you see the number of numbers divisible by 5 in this case will be 18. So favorable outcomes, and what is a favorable outcome in this case? Number divisible by 5. There are 18 such numbers. So the probability of getting number divisible by 5 is 18 total outcomes over 90. That is the favorable outcomes, that is 18 over 90, that is total outcomes, that is 1 by 5. A child has a dice whose 6 faces show the letters as given below. The dice is thrown. What is the probability of getting A? So first, always total outcomes or total events. And here we see it's 1, 2, 3, 4, 5, 6. So total events is 6. Next is favorable events. Favorable events. And in this favorable events is to get A. Now how many A's do we have here? We have 1 and 2 A's. So the favorable events here, number of favorable events, there are 2 events, 2 favorable events. So the probability of getting A will be 2 favorable outcomes over total outcomes, that is 6, that is 1 by 3. Now for the next part, they say what is the probability of getting a D? So probability of getting a D, so we have to first find the number of favorable events. Number of favorable events, and in this case the favorable event is D, so there is just one D here. So number of favorable events is 1, just 1 D, so the probability of getting a D is 1 out of 6. Suppose you drop a dice at random on a rectangular region as shown in the figure. What is the probability that it will land inside the circle with diameter 1 meter? So in the first step, we need to find the total area. Here is your rectangle, the length and the breadth. So we need to find the total area. So that will be the total area, which is area of rectangle the length is 3 meter and the breadth here is 2 meter. So the area is 3 into 2, that is 6 meter square. Then we must find the probability of it falling in this circle. So we got to find the area of this circle. So area of circle is pi r square. Now the r is given as 1 meter. The diameter is 1 meter. So the r is half meter. So it will be pi r is 1 by 2 the whole square. So pi by 4. So this will be the favorable outcome. So when it comes to the probability of falling in the circle will be total outcome, will be favorable outcome over total outcome. So pi over 4, favorable outcome over total outcome is 6, which is pi over 4 divided by 6. Pi over 4 into 1 by 6. Pi over 24 will be the probability. A lot consists of 144 ball pens, of which 20 are defective. So there are 20 defective and others are good. Nuri will buy a pen if it is good, but will not buy if it is defective. The shopkeeper draws one pen at random and gives it to her. What is the probability she will buy it? Now remember, she will buy it if the pen is good. So first we have total outcomes. So the total outcomes is 144 ball pens. The total ball pens. Out of these, defective are 20, which means the non-defective will be 144 minus 20 and 124. These are the non-defective, and she will buy a pen that is non-defective. That means first the probability that she will buy will be favorable outcomes. Favorable outcomes are the non-defective ones. That's 124 out of the total. Total is 144. That is 144. So that is equal to 31 over 36. She will not buy if they are defective. So how many defective do we have here? We know the defective are 20. So the probability that she does not buy will be the favorable outcome, in this case are the defective ones, over total 144. So that is 5 out of 36. Before we go on to the next question, let us see what is the sample space for two dice. If we have two dice, what would be the sample space? So we'll have one dice which has got numbers. So here is 1, 2, 3, 4, 5, 6 is one dice, we'll put it in green, and the other dice we'll put it in yellow. 1, 2, 3, 4, 5, 6. Now the possibilities could be, the first possibility could be 1 from here and 1 here, right? The next possibility could be 2 and 1. Then the third possibility could be 3 and 1. Then the fourth possibility 4 and 1. Then fifth possibility 5 and 1. Sixth possibility 6 and 1. In this way we keep writing all the possibilities. In this case it would be 1 and 2. Then we would have 2 and 2. Then 3 and 2. Next would be 4 and 2. Then would be 5 and 2. Then 6 and 2. In this way we will fill the entire table. So here's the next column. Then we can fill yet another column. That will be 1, 4, then 2, 4, 3, 4, and so on. This will be the fourth column. Then for the fifth column we will have 1, 5, 2, 5, then 3, 5. So this would be the next column. And for the last column it would be 1, 6, 2, 6, 3, 6. So if you see, if two dice are thrown, you get 36 possibilities. There are 6 here and there are 6 here. So 6 into 6 is 36. The total outcomes for two dice is 36. So here's the sum of two dice. Now they said, what is the possibility that the sum of both the numbers is 2? So for the sum to be 2, we got one possibility, and that is 1, 1. So it will be 1 out of 36. The next is, what is the possibility for the sum to be 3? And for the sum to be 3, we have one possibility, could be 1, 2, and the other one is 2, 1. So here the possibility 2 out of 36. Next is to get sum 4. And to get sum 4, the possibilities could be 3, 1. Then we have 2, 2. 2 plus 2 is 4. And we have a 1, 3. So we have 3 out of 36. Next, to get sum 5. Now to get sum 5, it could be 4 on one dice, 1 on the other. Then we have 3, 2, that is 5. Then we have 2, 3, that is 5. And 1, 4, that is 5. So we have, let's count the possibilities, 1, 2, 3, 4 possibilities of getting sum 5. So that is 4 out of 36. Then next we will see getting sum 6. To get sum 6, it could be 5 on one dice, 1 on the other. then we are getting 6, 4, 2, or it could be 3, 3, or it could be 2, 4, and it could be 1, 5. And if we count, this is 1, 2, 3, 4, 5 of them. So it is 5 out of 36. Next we'll do sum 7. And to get sum 7, it could be 6, 1, or 5 and 2, or 4 and 3, 3 and 4, 2 and 5, 1 and 6. And this again would be 1, 2, 3, 4, 5, 6. So 6 out of 36. 6 out of 36. Then next is sum 8. And for sum 8, it'd be 6 and 2, or 5 and 3, then it could be 4 and 4, then it could be 3 and 5, 2 and 6, that would be 8, and we have here 1, 2, 3, 4, 5 of them. So that will be 5 out of 36. Next is to get sum 9. Now sum 9, the possibilities could be 6, 3, then would be 5, 4, 4, 5, and 3, 6, and this would be 4 out of 36. Next is to get sum 10. So to get sum 10, it could be 6, 4, or 5, 5, and 4, 6. That will be 3 out of 36. The next is sum 11. Sum 11 would be 6, 5, or 5, 6. That is 2 out of 36. And then sum 12. And sum 12 is just 1, 6, 6. That is 1 out of 36. So now we can fill in. For 3 it was 2 out of 36. Then for 4, 3 out of 36. For 5, 4 out of 36. For 6, we saw it was 5 out of 36. Then for 7, 6 out of 36. 8, 5 out of 36. Then for 9, if we see the pattern, it is 4 out of 36. 10 will be 3 out of 36. And 11 will be 2 out of 36. The next part of the sum says, a student argues that there are 11 possible outcomes of 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Therefore, each of them has probability 1 out of 11. Do you agree with this argument? Definitely not. We have already seen that the sum comes different. The sum is not all same. For 2 it is 1 by 36. For the sum to come 3, for 2 it is 1 by 36. For 3 it is 2 by 36, and so on. A game consists of tossing a 1 rupee coin 3 times and noting its outcome each time. Hanif wins if all the tosses give the same result. If he wins if they give the same result. 3 heads or 3 tails, and loses otherwise. Calculate the probability that Hanif will lose the game. So first we have here 3 coins. So what is the sample space for 3 coins? For sample space for 3 coins, there are 3 coins, so we put head, head, and head. Then it could be, just keep head here, it could be head, tail. We leave head here, it could be tail, head. We keep head here, tail, tail. Now for the next one, we will now put tail and repeat the process. So it could be head, head, here tail, so it will come now this. So head, tail, so we will put tail. Now it would be this, tail, head, then you put tail again, and it could be this. So tail, tail. And if you count this, the total outcomes are 8 outcomes. So total outcomes are 8 when you have 3 coins tossed. Now let us see when he will win the game. He wins the game when he gets 3 head or 3 tails. So that means here he will win and here he will win. 2 out of 8. So for winning the game, probability of winning will be 2 out of 8. 2 are the favorable outcomes and total is 8. 3 heads means you have head, head, head. He will win, or tail, tail, tail. So 2 out of 8, that means 1 out of 4 is winning. So if you want to find the probability of losing, will be 1 minus 1 by 4, which is 3 by 4. Let's go over that again. Probability of win plus probability of lose equal to 1. We have seen the probability of win is 1 by 4. So 1 by 4 plus probability of lose equal to 1. So the probability of lose equal to 1 minus 1 by 4, which is 3 by 4. A dice is thrown twice. What is the probability that 5 will come either times? Now for 2 dice, a dice thrown twice is just as good as 2 dice. And we see the possibility is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Then here we have 2, 1. This is 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Then it will be 3, 1, 3, 2, and you just go on writing the entire sample space. 3, 5, 3, 6. So here is 4, 3, 4, 4, 4, 5, 4, 6. Then we have 5, 1, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, and last we have 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So total we have 36. Now here we have to see where 5 will not come. So 5 will not come, and if you look up here, the number of outcomes when 5 will not come will be 11. Like these, see here, 1, 2, 3, 4, 5, then 6, 7, 8, 9, 10. It's not 11, will not come. So you have here, you keep on 1. These are all that 5 will not come. Here, this is 5 here. This is all that 5 will not come. Here there's all 5. So these will be the 5 that will not come. And if you add them up together, they work out to be as 25. So 5 will not come are 25. So the probability of 5 will not come equal to 25 out of 36. So if we were to ask you, what is the probability that the 5 will come? 5 will come will be the rest of them. So 36 are the total. 5 will not come is 25. Therefore the 5 will come will be 11. So probability that 5 will come equal to 11 out of 36. Remember, this 25 is where 5 will not come. So the one that will come will be 36 minus 25. So 11 is when 5 will come. 11 times, and you can find out here. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 times 5 will come. So the probability will be 11 out of 36. Is a given statement correct or not correct? If two coins are tossed simultaneously, there are 3 possible outcomes. Let us see if two coins are tossed. What are the possible outcomes? So for 2 coins, it could be head, 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 tail, tail, head, tail, tail. So the total outcomes are 4 outcomes. Now here they say there are 3 possible outcomes, which is definitely not right. There are 4 outcomes. 2 heads, 2 tails, and 1 of each. Therefore, each of them will have 1 by 3. No, that's not right, because we have seen the probability of getting 2 heads is here 1 by 4. Then the probability of getting just 1 head, this is 1 head and this is 1 head, that is 2 by 4, 1 by 2. The probability of getting a tail, 2 tails, here there is only 1 probability. The probability of getting 2 tails is 1 by 4. And the probability of getting 1 tail, here's 1 tail, here's 1 tail. So probability of getting 1 tail is 2 by 4, that is 1 by 2. So this is false. The next statement, if a dice is thrown, there are 2 possible outcomes, an odd or even number. Therefore, the probability of getting an odd is 1 by 2 and even also is 1 by 2. So for the second one, we're talking about a dice. And in the dice, we see the total outcomes is 1, 2, 3, 4, 5, 6. These are total outcomes. Probability of getting even is 1, 2, 3. That is 3 out of 6. 1 by 2. And the probability of getting odd is 1, 2, 3. That is 3 again by 6. That is 1 by 2. So this is true.